And well, I'm here just to know, like, how many of y'all are developers here, like technical people here who are like programmers, I would say? Okay. Just ask because I want to like calibrate my talk a bit, because this is going to be a bit of a hands-on session. So no worries, if you're non-technical, you'll still learn a lot in this session. So what we are going to look at is how do we program for the Microsoft HoloLens? How do we develop apps for the HoloLens? So you just saw the previous session. I think you got a good grasp of what the HoloLens is and how it can be used in a particular domain, specifically the healthcare domain, as discussed in the previous session. So what I'm going to address here is like basic developer questions, like, okay, as a developer, where do I begin? Where do I start to start programming apps for the HoloLens? So this is just a short roadmap of what we are going to do in the next few minutes, and we'll try to cover this in the next 20 minutes or so. And actually, one thing we need to understand before we go into any demos or anything is what are mixed reality applications. So these are new words that's come up. We have heard of virtual reality. We have heard of augmented reality. And when it comes to the HoloLens, we see this term mixed reality. So basically, if you look at virtual worlds or virtual reality, the keyword there is presence, you could say, because you're immersed in it. The virtual world surrounds you. And if you're looking at augmented reality, you would have had a good idea that, okay, augmented reality is like kind of overlays. I would take Pokemon Go as an example, because for example, when you look at a Pokemon through your phone, you can see it's overlaid on top of the actual existing world, but you don't see the length contraction. You can easily break the fact, or you can easily break the fact that it is not actually part of the real world. I mean, your brain will tell you that it's not real when you do certain things. So mixed reality is a bit different. It is actually digital artifacts, like what we saw. You saw so many holograms hovering around. These are digital artifacts which coexist in your real space, and which can actually interact with you in real time. And for the purposes of developing for the HoloLens, these are what I would say are the fundamental points that we should look at when we are developing applications for holographic devices such as the HoloLens. So basically, we have world coordinates, we have voice input, gaze input, we have something called spatial sound, gesture input, which you just saw. There are two types. There is what is known as the air tap and what is known as the bloom. And then you've got spatial mapping, which is a very deep and specialized topic in itself, where the HoloLens knows how to map the interior of the building you are in, and it knows that this is a solid wall, and that's going to be a roof, and there are steps here. So that's called spatial mapping. So if you notice, these are a bit different types of input from the regular, 3D games you have played, or it's very different, and it's very immersive, and it blends reality together with the digital world. So to get to the matter, we want to develop for the HoloLens. Basically, Microsoft and Unity has provided us some really great tools, and what we need is Visual Studio 2015 Update 3. Any version will work. The community edition is free, so even that is going to work. When you're installing, you have to make sure that the tools and Windows 10 SDK is checked under the Universal Windows App Development Tools node, which I will just show in the next slide. And then we have the HoloLens emulator, which is also available for download. And then we have the Unity HoloLens technical preview, which Unity has built specifically for development on HoloLens. And this is what I mentioned in my previous slide. When you're installing Visual Studio, you have to make sure that you check the Universal Windows App Development Tools, which I have just marked in red there. Okay, when it comes to the HoloLens technical preview from the Unity website, if you just search for Unity HoloLens technical preview, you will come directly to the website. And don't worry about the resources and the links. Everything is here at the end of the slide. I've compiled all the resources in a list. So when you're downloading the Unity HoloLens technical preview, you may run into two types of issues. One is you may run into a problem where the file or the setup file does not download properly. The second type of problem is once you download it and you run it, it may not install correctly. So no need to panic in this case. All you need to do is just go to the tab that says Archive and just download a previous beta of Unity HoloLens Technical Preview. So it will be known as Unity HTP. And you can continue with the previous beta of the software as well. And one important thing when you're installing the Unity HTP is also, again, when you're installing that, you will have some options. And one of those options would be Windows Store.NET Scripting Backend, which is very important, which is required. Otherwise, you will not be able to import your Unity files into a Visual Studio project, which is required, as you will see in the hands-on demo. And in terms of hardware requirements, we need a decent machine of about 8 GB of RAM or more. We need a GPU. We don't need anything with highly specialized graphic cards like you would in a gaming machine, but you need something that supports DirectX 11 or later and the Windows Display Driver Module 1.2 driver or later. And of course, you need a 64-bit CPU, CPU with basically 4 cores or similar, multiple CPUs with total of 4 cores. And for the platform and OS requirements, you will need a 64-bit Windows 10 PC, which is either a Pro, Enterprise, or Education edition. Home edition is not supported because of the second point here, enable Hyper-V in Windows. So we need to enable Hyper-V for the HoloLens emulator to work properly. And because Hyper-V is not supported in the Windows Home edition, we cannot use the Home edition. And Hyper-V can be enabled when you go to your Windows features, when you turn Windows features on and off. And you need to set these BIOS settings. More often than not, they're already set. Sometimes maybe the hardware-assisted virtualization may need to be adjusted. But this HAV and the SLAT, second level address translation, and the DEP settings should be set properly in your BIOS. So that's pretty much the basic requirements that you need for developing a HoloLens app. That's the machine requirements and the software you need. So let's just dive into building a HoloLens app and just checking how the flow goes. So I have not opened up any software here in preparation for this because I want you all to see the flow and the sequence of actions I do so that you all remember it better. So first, I'm going to start with Unity HoloLens Technical Preview. And here we are going to start with a new project, with a project space here, and a project name. And make sure you select the 3D option. So you come into your workspace in Unity. Unity is actually basically, if anyone has not heard about Unity before, it's a cross-platform game engine. It can target multiple devices, multiple platforms, like mobile devices. And right now, Unity has come out with this HoloLens technical preview for the HoloLens, which is what we're using to develop a basic HoloLens application. So Unity in itself is a very vast topic, and I would recommend you all read up a bit about Unity and especially Unity API scripting. So here we have something called a main camera, which we are going to kind of offset to an origin here. You can see X, Y, Z locations. And if you remember in the previous session, when we actually put on the HoloLens, we were kind of the first-person camera. So if you're playing a computer game, let's say you're playing a first-person computer game, your computer monitor is the first-person camera. But with the HoloLens, your eyes themselves become the first-person camera. So basically, we need to calibrate this position to 0, 0, 0 in the 3D coordinates. And then next, we need to select this skybox setting to something called solid color. And we need to set that solid color to complete black. Now, the HoloLens is a device which adds light to what you can already see, meaning which if I'm wearing it now and I see you or anyone in front of me, the device does not take light away from my eyes. It cannot do that. It can only add, which is why you saw the holograms. So basically, the device cannot create the color black, because black means you're taking light away from the eyes. So due to that, when we specify everything as black, that black portion is rendered as transparent. So anything red that the device tries to render as black is rendered as transparent. So basically what I told this camera is, okay, I want to see only the background. I want to see only the transparent screen in front of me, which means like if I wear the device with this setting right now, I would see all of you right in front of me. Whereas if I had selected the skybox, I would have seen that particular view, what you see here on the screen right now, instead of seeing all of you. Okay, so moving on, we have one more setting here, and that is called the clipping plane. And this is actually a recommendation by Microsoft HoloLens team to have it to something called 0.85. A clipping plane is basically a plane in your 3D field of vision here, which is this rectangle. If you can see my mouse pointer, it's this rectangle which I have increased to 0.85. So any object in front of this plane will not be rendered, and any objects inside this plane will be rendered. And that is called the near clipping plane. And that's basically due to the calibration with our eyesight. So basically, they have come to the conclusion, or Microsoft recommends us to have a near clipping plane of 0.85 meters. And everything you see here, any numbers that we put on the right-hand side is all in meters, because the HoloLens itself will translate any value or unit we put here as a meter. And if I say, for example, we are going to add a cube, and we are going to say that this cube is going to be 5 units in front of me, that actually translate to 5 meters. So it's very easy to develop. Any number you put here translates directly into meters in the real world. So right now, I've just configured this cube to be 5 meters in front of me, which is how it will look like if I was really wearing a device. So next, we have a camera, we have a cube. Next, we'll do something a bit colorful because this cube looks very plain. I've got something called textures. Textures are nothing but image files. If you see here, this is just a JPG file, .jpg. And what I'm going to do is I'm just going to drag it down here to this panel in Unity. Which will add it here. So first of all, let me save my project here. Okay, so we have a texture file here, which is basically any image that you can just drag into this work area. And next, we are going to create something called a material. And we are going to call it cube material. And to this cube material, I'm just going to drag this texture right up to this first selection, where this selection called albedo is already selected, and I'm just going to drop it there, which is going to apply that texture to this material object. I can see the kind of a preview of it here. And you can play around with these settings. It increases certain diffuse colors and how the reflection. And basically, once you're satisfied with the material preview you have here, you can just drag that material object, game object, onto that cube to texture it. So now if I switch to my game tab here on top, this is basically what I'm looking at, a cube, 5 meters in front of me. Okay, so to speed up things a bit, let's make a few copies of this cube. What I did was I just did a Control-C, but let me do it like this. So now we've got 3 cubes, which we are going to place in a straight line in front of us by giving +3 and -3 to the x-axis here, so that it looks like that. And let's add something new. Let's add another object. Let's say a sphere. Let's put it 5 meters in front of us and maybe 2 meters. Let's say 6 meters in front of us, 2 meters up, yeah. And let's quickly create a material for the sphere as well. And I've got some more textures which I can use. Let's say, for example, this frosted glass texture. So same procedure as the cube material. You select the sphere material that you just created and drag and drop the texture onto the first selection. Play around with the settings. And once you're happy, just apply it to the new object you created. So just a note, it's always the material game objects that you apply to the 3D spheres or cubes or meshes that you create. It's not the image directly. So now you should have a pretty good view of what we created. And just to add one last thing, just to showcase what Unity can do, let's create a small C# script, and let's call it spin. And let's open this, and if you open, you will see that it opens in by default in Visual Studio. There's a very simple class with 2 empty methods here called start and update. Actually, I'm not going to use any of this. I've got some very simple code written here to save some time. And we are going to put it here. So this is nothing complicated. This is just basic Unity scripting. You can use JavaScript or you can use C#. And I'm using C# here. This is just basically telling Unity, okay, do transform, do a rotate command for me using this vector. Using this speed variable, which I have defined as 20. It's a floating point. into the time.delta time. Delta time is simply just Unity's way of identifying the time elapsed since the last rendering, last frame rendered. So basically, you can do a lot of things with Unity scripting, so I advise you all to read up a lot about that. These are very simple things with regards to that. So all you need to do is just save this script, close it, and yeah. So if you see the right pane here, it should reflect the changes you did just now in your code. So what you can do is we can basically apply this script to an object. Let's say the middle cube that we created. Let's just drag and drop it to that. And I'll just save my project. And now to see the effect of a script, what I can do is I can just click this play button. And I will see that, okay, I've applied the script to that cube in the middle, and now it's started to rotate. And if I go back to the scene, the play doesn't stop. It still goes on rotating. It shows me what the script does to that object in real time. So I can click play again to stop the real-time rendering of the effects of the script. And basically, we are done with our creating our, the meshes and cubes and all that. So basically, we'll move on to how to deploy it in HoloLens. So now, next, what we're going to do is specific to the HoloLens technical preview. So first, we'll go to Edit, Project Settings, and Quality. This is something you can never be sure of, so always it's safe to check the quality settings. And I came to these settings from Edit, Project Settings, Quality. And here, under the Windows Store tab, you can see here that there is a Windows Store tab here. So here, you just select this drop-down and you select Fast. I mean, we would love it to be fantastic, but it won't be fantastic if it crashes due to rendering issues and all that. So let's just have it fast for now and save. And let's see how we are going to build this into a Visual Studio project. So first, we'll go to the Build Settings. And here you will find a list of platforms, target platforms that Unity can build game objects for. And what I need is the Windows Store. And I will select the SDK as Universal 10. The Universal Windows Platform build type is Direct3D. And here is a very important thing which you might want to keep in mind is this player settings. You need to click on player settings and scroll down on the pane that appears to your right. And you need to select virtual reality supported because this option is not there in any Unity version which is not a HoloLens technical preview. You won't see this. So you need to select, first of all, you need to install Unity HTTP correctly. And then when you're building, you go to player settings and select virtual reality supported. And make sure that Windows holographic is selected as a virtual reality SDK here. If it's not, just click this icon here and select it. So actually, that's most of the work that we need to do in Unity. Basically, we need to add open scene here, which will add our current scene that we have created. We'll just make sure that everything is the correct settings that we have given it. And finally, we can go to build settings. When you select add open scenes, it will add any open scene which we have created in Unity. Universal 10, Direct3D. And then you have to check this checkbox, Unity C# projects. And then you say build. So here it asks me a folder. Okay, where do you want the output? Where do you want the Visual Studio project output? And I'm going to create a new folder called Visual Studio app. And I'm going to select this folder. And now it starts building. So building is a bit of a time-consuming process in Unity. So basically, the HoloLens specific things that we actually did in Unity was to calibrate the camera to come to a origin in the world coordinate system. That means X, Y, Z should be 0, 0, 0 as far as the main camera is concerned. The background should be solid color, and the RGB values should be 0 again. And of course, in the build settings, we need to select the Windows Store target with the Universal 10 and Direct 3D options. And most importantly, in the player settings, you need to select the holographic application checkbox and select the SDK, Windows Holographic SDK. This is actually the basic minimum to import a Unity project to work with the HoloLens device. So now, once it finishes building, it opens the folder again and shows me, okay, now we have built it, and we have the project files inside. So what I'm going to do is I'm going to close this. I'll just save this and close this as well. So the next step, I'm going to open Visual Studio 2015 in administrator mode, quite important. Otherwise, you're going to get a lot of issues with the emulator. Once the emulator starts running, you're going to get a lot of permission issues. So once Visual Studio is up and running in admin mode, we are going to open the project that Unity just created for us, which is inside Unity Projects, DevDay HoloLens 101, and VS App. And here's the solution file. I'm just going to open that. So here you can see a couple of projects. You actually need to look at one file here. That's the package, the manifest file of the application. You just need to click View Code to see what's in there, and we need to change one thing. And that's in this tag called Target Device Family. Because when UWP first came out, the Windows Universal Platform, Windows 10, everything came out, they had one name for everything called Universal. But now the devices are very different, and Unity could have imported this for Xbox or for something else. So now we have specific names. So in this case, actually, it's going to be holographic, which we need to change here. And sometimes this min version and max version tends to become the same. It actually should be this value here, 10586 should be the max version tested. Okay, so basically that's pretty much there is to it. The only code we wrote was in the Unity scripting, and that was just 1 or 2 lines of code. So let's select a release configuration. And x86. And assuming you have installed the HoloLens emulator correctly, you should see the HoloLens emulator as a debug device here. And then we just need to say start without debugging. Again, it's recommended that if you all are working with the HoloLens emulator, that you all instantiate it one time and keep it running without closing it, because it's an expensive operation to start the emulator. It takes a bit of time, but in this case, I just wanted to do everything from scratch and not have everything ready, just so that you all can follow the sequence. So right now, the project is being built. And that's the emulator starting up. So the emulator is pretty much the real thing that we just saw earlier. It's just, it can mimic everything. It can do everything the real device can do in terms of the software. It actually runs a fledgling Windows 10 software inside this emulator. But one thing you will notice is that the background will always be black color. That's because in the device you will actually see what's in front of you through the glass. But here the black color means okay, it's going to be rendered transparent once this is deployed to actual device. So this is what we saw in the device earlier as well. And I can use the right click, and moving around my mouse I can navigate. And I'm just waiting. If you can see in the background here, it says deploy started, so it's deploying my application to the emulator. Okay, it said deploy succeeded. And there we are. So we are seeing this inside our emulator, and I'm going to just use the mouse to look up and down to the sides. And I'm going to move behind using the S key. And at the same time, I'm going to be looking around. So these are like basic, very simple geometric objects placed in the real world. Anything, all this black that you see here will be replaced by what's behind the lens in the real device. So we can move through the objects, we can move around the objects, we can view the objects from different vantage points. So basically these are, as far as the emulator is concerned, these are practically all around you. Okay. So one more thing I just wanted to show you all, which is quite useful for a developer, is this device portal here. If you click it, you'll be taken to a website where you can actually see the diagnostics, the file explorer, the logging, the system performance of the okay, right now it's showing me the system performance of the emulator. But in the earlier session where Rafiq used the same portal, you would have seen the performance of the actual device he was using, and you would have seen the processes that was running in the device. And you have the 3D view where the emulator is looking at right now, currently. And when I move in my emulator, it kind of mimics it in real time in my 3D view in the device portal as well. And if I want to see where I really am inside the application, I would just update this spatial mapping here, which would actually render a pre-built room that I am in. So through my emulator, this is actually what I'm looking at, though everything looks dark here. So these are very interesting and useful tool for a developer. You can do a lot of debugging from here itself. And that's how you develop a basic simple application for the HoloLens with just 2 or 3 lines of code and a little bit of clicking and dragging. Okay, so hope everyone was clear through the demonstration and the steps. So if anyone has any questions or wants to reiterate any step I did, now's the time.
Do we really need Unity for this?
Do you need Unity to develop for the HoloLens?
Yeah, really need, or we can just rely on the Windows 10 SDK?
No, you don't need Unity. But if you don't use Unity, it's going to be a very hard approach because you're going to directly talk to the DirectX APIs. So if you have done any DirectX programming using iFramework view, you're going to go through that model of development. What Microsoft recommends is to use Unity, and that's why they're working together with Unity to develop this HoloLens technical preview. Otherwise, Unity didn't actually have much of initiative to venture into this because it's still a develop edition.
Okay, so then can we get all the SDK libraries which we are using in the Windows 10 in the Unity, since it's a mono framework, right?
Yes, actually, Unity integrates with DirectX because the target is the Universal Windows Platform, Direct 3D that is already there in the Windows SDK.
Okay.
So basically, Unity just integrates very simply with that.
Okay, thank you.
Okay, so.
All right, thank you guys for that session. Thank you, Mark, for your session.